Hi, this is Celine. I went to school at dentist school in Venezuela and living in Katy, Texas.
Oh, great. Okay, perfect.
Thank you.
Awesome. Okay, and Stan. Okay, Stan. All right. Okay, are y'all ready to rock and roll? So everybody, so you see we got a wonderful group here, a wonderful group. So tonight, the goal tonight is to go over the high yield biological compound notes that you need to know for this section of the NBDE, okay? So is everybody ready? Everybody ready to go? Okay. Now, when we study, when we do questions, when we go through things, I'm going to point out some things that you got to know for sure on the test, okay? Things you got to know, all right? So the first thing is you'll see that I'll call out certain people on certain things, okay? So I'll call you out on certain things that I think you should know. Now, the first thing I'm going to do is I'm going to share my screen with you, and we're going to have some, we're going to go through a few topics on the NBDE regarding biological compounds, okay? And when you can see my screen, just let me know that you can see it. And let me pull this up. Okay, here we go. All right, can you all see my screen okay? You can, perfect, good, good, great, awesome. All right, so the first thing that we're gonna do is let's talk about, and we're gonna go through some basics first. Anytime I see the word OSE, what does that imply? As soon as I see that on the test, what do I know that means? Good, Amira. Perfect. That's right. Exactly. Good, Pedro. That's right. So we know that's a sugar. Okay. Perfect. So on the exam, don't you think it would be important if we know the difference between our monosaccharides, right? Our monosaccharides and our disaccharides. Okay. Now, let's see here. Amira, what are my monosaccharides?
Glucose, fructose, and galactose.
Outstanding. Thank you. All right. Did everybody see that? Everybody got that? So those are my monosaccharides. Now watch this. Now with my disaccharides, all of my disaccharides have what in it? Which monosaccharides do all disaccharides have? Yes, exactly. Glucose. You got that? That's right. So that means glucose plus something is going to be a disaccharide. Does that make sense? Yeah, I know. And I know what you're thinking. You said, wait a minute, that's too simple. They're not going to ask me anything that easy on the NBDE. Well, you're right. But they're going to ask you something like this. Watch this. If you know that all disaccharides start with glucose, right? Plus something else. So if I put glucose and glucose together, what does that give me? Okay. All right. Everybody says maltose. Everybody agree? Yes, I like that. Okay. If I put glucose and fructose together, what does that give me? Here we go. Now, you want to know what's money on the test? This one right here. You see I put this star by? That is money on the exam. You know why? Because they will ask you so many questions about this sucrose, right? But here's the thing. As long as you know the root SCU, right? SCU, suc, you're going to get the answer right. Now, if I see ASE at the end of a word, what does that mean? Good, Amira. Good, Stan. That's right. Okay, everybody got that? So as soon as I see that, I know it's an enzyme, right, Keela? That's right, it's an enzyme. And what does an enzyme do, Pedro? What does an enzyme do?
Sometimes it breaks down some particles or is like an activator.
Okay, perfect. So basically what Pedro said is that an enzyme is basically a catalyst. So it catalyzes some type of reaction. It means it can break it down, it can synthesize it, but it has different functions, right? But it's a catalyst. So if I saw the word sucrase, what do you all think that means? What is sucrase? Okay, it's an enzyme. What does it do? Amir says it's going to break down sucrose. Perfect. I love it. It's true. Good. Now, if sucrase breaks down sucrose, what is it going to break it down into? Glucose and?
Fructose.
Perfect. Good. Okay, everybody got that? So glucose and good for Thema. That's right. Good, Reem. That's right. Exactly. Now watch this. Do you know on the exam, if that seems like a simple concept, doesn't it? Doesn't that seem like super simple? Now, what if they put something like sucrose, one sucrose transferase? Okay, how many of you know this? What this enzyme is right here? How many of you know this? Anybody? Anyone? Anybody? Yes, no, maybe. Okay, good. You know what? Guess what? It doesn't exist. It doesn't exist. But you know what the cool thing about this is? Is that the point that I'm making is, look at this right here. As soon as you see that, you think what? You think sucrose, correct? Perfect. As soon as you see this, you think of an enzyme. So regardless of if you've heard of it, you know the roots to it. So when you look at your answer choices, what are you going to be looking for in your answer choices? How about something dealing with glucose or fructose? Y'all follow me? Does that make sense? Nada? Good, Nada. Do y'all see that? Do y'all follow me? Okay, now watch this. If you have, just say I take this, here's my glucose, right? Watch this. Say, for instance, I have this glucose, right? And I hook these glucoses up like this. This is a bunch of glucoses, right? So I see all these glucoses. I'm going to call all those glucoses together. I'm going to call those, and I'm going to give them a name called dextrans. Everybody follow me? That's dextrans, all right? Now watch this. I do the same thing with my fructose, and I call these polymers of fructose. What am I going to call these polymers of fructose? Yes, exactly. Oh, wait a minute. I know what you're saying. Hold on. You're saying, Dr. Sutton, that's not how you spell Levans. You don't spell Levans with an F, do you? I spell Levans with an F because if I can remember the F in Levans, I can remember the Levans, and I just think about fructose. Everybody follow me? So I'll never ever forget that fructose are the Levans, glucose is the dextrans. Everybody got that? Now watch this. Now, if you look at glucose and fructose, right, as Levans and dextrans, which one can cause dental caries? Which one of these causes the dental caries? Pedro says Levans. Amira says oh, okay. Now, I said, which one of these causes dental caries? You see that, Pedro? dental caries. There we go. Y'all got that? So dextrans are the dental caries. Okay? Everybody follow? That makes sense? Awesome. Awesome. Okay. So far, everybody got that. All right. So you told me that glucose plus glucose is maltose. I'm just abbreviating. You told me that glucose and fructose are equal to sucrose. And then, of course, glucose and galactose are equal to what? Lactose. Exactly. All right. Now, is there a reason that we need a monosaccharide? Why does your body need a monosaccharide? Why? Oh, good, Satara. I like that. I like that, Satara. All right. Does anybody know what I'm drawing right here? Anybody have an idea? Yes, Karina. Good job. This is the brush border, right? This is the brush border of what? The small intestine. Okay? You got it? Oh, wait. Can you all hear me? You can? Okay. All right. Ruby said no. Okay. Everybody else can hear me okay? So, Ruby, you may have to go out and come back in. Like, go back out and come in, okay? Okay. All right. So, this is the brush border of the small intestine. Now, what is the function of the small intestine that you need to know for the test? What's the function of the small intestine? Yes, it's digestive. Good, Ring. That's right. Absorption. Good, Sakshi. Right. Good. So the function of the small intestine is absorption, right? Now, when you absorb something, do you absorb big things or small things? Yes, exactly. Now, if you absorb small things, doesn't it make sense to have an enzyme at the brush border so you can break the big things down? Does that make sense? Okay. Okay, Nada, good. Karina says yes. Okay, so name one enzyme you would find at the brush border. Name one enzyme you think you would find. Good. I like that. So you would find sucrase for sure. Okay, that is awesome. So you would definitely find sucrase at the brush border. You would find maltase. Oh, I see you all got it. That's right. Right. How about lactase? Would you find lactase at the brush border? Yes, exactly. Now, does that make sense? Because if we have lactase, sucrase, and maltase, we can break down the what? We can break those disaccharides down, right? Exactly. Good. Good, Keela. Good, Amira. Good, Pocky. Sasha, yes. Now watch this. Oh, okay. So what I was saying, Ruby, is that I said at the brush border of the small intestine, right? You're going to have enzymes because the small intestine is going to absorb small things, right? Small things. So you're going to need to break down your disaccharides to monosaccharides. So you would need to have an enzyme, ASE, that breaks down your disaccharides. And guess what they are? Lactase, sucrase, maltase. Now, have you ever heard of anybody who was lactose intolerant? Have you all ever heard of that? Yes, exactly. Yeah. And so if a person is lactose intolerant, which enzyme are they deficient in? Exactly. Lactase. Lactase. Because they're deficient in lactase, that means they can't break down what? Lactose. So lactose increases. Does that make sense to everyone? Awesome. Good job. Okay. All right, so now watch this. So now we understand the basics of sugars, okay? Now, when we talk about metabolism, we're going to talk more about how we break them down at the molecular level, like at the very small level. But for right now, that's all you need to know about the disaccharides and monosaccharides for right now, okay? Now, the next thing I want to show you is this, and let's look at this together, have you ever heard of the term reducing sugar? Have you ever heard of that before? You heard of that? Okay, everybody has? Now, let me tell you all this. Please, if you have not heard of it, put no. It's okay, because we're in this together, okay? And the only way I know if you know something is if you say yes or no, okay? So reducing sugar. Now, when we say reducing sugar, let's see here. Let's go with Keela. Keela, turn your microphone on.
Okay. Yes.
All right, Keela. Okay, am I saying your name right?
Yes.
Kayla. Okay, good. Okay, so Kayla, this is what we're going to do. And Andrea, we're about to explain that right now. So Kayla, what is oxidation?
Reducing.
As the what?
Sugar.
Yeah, but what is oxidation? If you had to define it, what is oxidation?
To lose an electron.
I'll give you a hint. Go ahead. I like that. So you can lose an electron. Okay, what is reduction? Look at that G. There you go. Good job. Thank you. Very good. So now, that's great. Okay, you can turn your mic off. Good job. Thank you. Now, let me give you all a little bit extra. Did you know oxidation also means to gain oxygen? Okay? So oxidation also means to gain oxygen. And reduction also means to gain hydrogens or protons. Okay? Everybody with me so far? Everybody with me? Okay. Now I need you to visualize something for a minute. Okay? I need you to visualize this because this is going to help you answer one of the questions on the exam. So watch what I just do. Watch what I do. Now, I can't draw, so forgive my drawing. But in this person's hand, this is me, right? I have this electron, okay? Everybody with me so far? And this is somebody else right here, okay? I am going to give them my electron. What happens to me? If I give them my electron, what happens to me? Good, Karina. Good, Satara. Prathima, good. So Stan says, okay, you're right, Stan. You do become more positive. That's true. But the term that we're looking for is that I become oxidized. Does that make sense? Because I lose an electron. Everybody got that? Okay, Andrea, you got that? All right, perfect. Okay, good. Now, I'm going to put this over here as you. Now, if I lost the electron, that means you did what? What happened to you? Good, you were reduced because you gained the electron. Outstanding. Now watch this. Now watch this. Who was responsible for causing you to be reduced? Who was responsible for that? Okay, good, Karina. That's right. I was. Exactly. So since I was responsible for doing that, I am called the reducing agent. Does that make sense? Everybody understand that? Because I caused you to be reduced. All right? Now, that means if I'm the reducing agent, then you are the oxidizing agent. So if you look at this, whatever is reduced is the oxidizing agent, and whatever is oxidized is the reducing agent. Does that make sense? Everybody got that? Okay, great. Now, you're probably wondering, how am I going to use that on the exam? Like, what is that going to do for me on the exam, right? Well, here's how it works. They're going to ask you which of the following is not a reducing sugar. So they're going to say, which of the following is not a reducing sugar? All right. Do you all know the answer to this? Oh, Prathima, go ahead. Go ahead, Pocky. Good. Exactly. That's right, Kayla. That's right. The answer almost all the time on the NBDE is sucrose. All of your monosaccharides, and most of your disaccharides are reducing sugars, except sucrose. That's the answer you're looking for on the exam. Everybody got that? All right. So don't forget that one. Sucrose is going to be your answer. All right. Any questions on that part? Everybody good? Okay. Hold on just a second. Let me pull this up. Give me 1 second. Hold on. I'm trying to pull up the screen. No, reducing sugar, Satara. So, the question was reducing sugar. Oh, Andrea, good question. Okay. So Andrea asked a great question. Why is sucrose not a reducing sugar? Okay, here it is. So you remember, ooh, y'all gonna love this part. Let me show you. Now, this is getting a little deeper than what the test is gonna ask you, but I like explaining stuff. So we have sugars that we call aldoses, and we have sugars that we call ketosis. Now, if you see an aldose, you think of a group called, or a functional group called an aldehyde. If you see a ketose, we think of a functional group called a ketone. So what does that mean? An aldehyde looks like this. Now this, honestly, y'all, this is going a little deeper, but the functional group of an aldehyde is just the letter A. It's just a proton, okay? The functional group of a ketone is just another R. Now, the R is just a carbon group, like a bunch of carbons connected together. So, for instance, if I have carbon, 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 right? Double bonded, carbon, 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 right? And so you put R just so you don't have to write all the carbons out. Does everybody understand that? Y'all kind of get that? Okay. Now, the reason that I wanted to show you this is because good. Nada. Okay, yeah. So Nada is talking about an aromatic carbon. So basically what Nada is mentioning is this. If I see X, Y, A, B, right? Around this carbon, are there 4 different groups around this carbon? Are there 4 different groups? Yes, there are. So if there are 4 different groups, right, around the carbon, we said it has a chiral center. They're not going to ask you this on the test. I'm just explaining it to you, but they're not going to ask you this. Okay? Sucrose, when you look at sucrose, right, the reason that sucrose is not a reducing sugar is because in order to be a reducing sugar, you have to be oxidized. You have to have the ability to be oxidized. That means then you have to have the ability to lose an electron. Does everybody understand that? Okay, good. If you look at the structure of sucrose, and I won't pull it up here, but if you go back and you look at the structure of sucrose, in its structure, you will see that it is very difficult for sucrose to lose an electron, just based on the structure. So if that's answering the question, basically the reason that sucrose is not a reducing sugar is its difficulty to lose an electron. Okay, you got it? Okay, perfect. Okay, good, good, good. Okay, now watch this. Let's go to the next thing. Let's watch this. All right, so everybody's good with this part, right? Everybody's good with this? All right, now let's go down. Let me scoot this over just a little bit. Okay. Here we go, here we go. Okay. Oh, Ruby, you said, okay, Mira, my question, if reduction also means gaining a proton, and how is it getting, oh, hold on, that's good. Okay, so, let me answer Ruby's question, and then I got you, Amira, okay? So Ruby's question basically was, again, about sucrose. So we said sucrose, not a reducing sugar, okay, Ruby? And it's not a reducing sugar because it is difficult, right, for sucrose to be oxidized. Okay, you with me, Ruby? So it's difficult for sucrose to lose an electron. So that's why it's not a reducing sugar. All right? Now, reduction means you gain an electron, right? You gain an electron. If you gain, reduction is gaining an electron, that makes you more negative because electrons are negative. So if you are reduced, you're gaining electrons. You got that, Amira? Now, let's go with the protons. And I should have said, I should have been more specific. I'm sorry about that, because I think I did say that, but it's gaining a hydrogen, okay? And when I said protons, it's because a hydrogen is made of one proton and it's made of one proton and one electron. So you're gaining, that reduction also means to gain a hydrogen, which means basically it's one proton, one electron. You follow me? Okay, you got it? Any other questions on that? Everybody got that? Okay, so let's go ahead and go to the next thing. Right, it's just the hydrogen, exactly. It just means it's just gaining a hydrogen. That's exactly right, okay? All right, so we looked here at the brush border. Everybody's good with the brush border? We talked about the brush border, okay? And let's go down now. This is the next piece I want to show you. And this is it right here. All right, let me scoot this over just a little bit so y'all can see that. Okay, so does everybody see right here? Can everybody see the screen where it says most reducing sugars? Can you all see that? All right, most reducing sugars have a what group? An aldehyde, exactly. And you remember I told you the aldehyde is only signaled by this H. Do y'all see that H right there? That's how you know it's an aldehyde, okay? So that's it right there, okay? Perfect. Now, we've already talked about the oil rig, so everybody's good with the oil rig. Hold on while the computer catches up, okay? All right, now let's look at this right here. This is always a test question, always. So they normally will find some way to ask this question. So you remember we talked about these dextrans, right? Now with these dextrans, they have two types of linkages that you need to remember, okay? So you got a 1,6 linkage. You see that 1,6 right there? 1,6 linkage. Now, glucose has how many carbons? How many carbons does glucose have? It has 6. Perfect. So if you think about glucose, you write the formula C6H12O6. Okay? Everybody follow me so far? So that's the formula for glucose. C6H12O6. Good, Stan. That's right. So if you think about, okay, how do I remember the linkage, right? The linkage between the dextrans. Always think to yourself, dextrans are glucose. Glucose has 6 carbons, so maybe I can remember a 1,6 linkage. Does everybody understand what I mean when I say 1,6 linkage? Does everybody understand that? Okay, Amir, okay, no problem. Okay, so here we go. Watch this. Okay. So if you look at a glucose, right? And we said that glucose is C6H12O6. Everybody follow me so far, right? 1, 2, 3, 4, 5, and 6. Okay? And then each one of these carbons are covered by this hydrogen, okay? And what you do is you number the carbon. So say this is carbon number 1, this is carbon number 6, okay? And then you have another carbon, here's another glucose right here, C4, 6, okay? And we're going to call this one number 6. We're going to call this carbon number 1. If carbon number 1 is connected to this carbon number 1, right? So here's a glucose. Here's another glucose. If this glucose, carbon number 6, is connected to this glucose, carbon number 1, we call this a 1,6 linkage. Everybody follow me? And you remember, when you connect these glucoses together, right, when they're all connected together, a polymer of glucose is just called dextran. So that's why dextran has a 1,6 linkage. Does that make sense to everybody? Everybody good with that? All right. Perfect. All right. Let's go to the next topic. And at any point, if there's something that you don't understand, stop me, okay? Because the key thing, what is the key thing for us? Everybody in this class, what is your one goal? What is your goal? There you go. Thank you. Pass. So the only way we can do this is by asking questions, right? You got to ask questions. And that's why I'm here, okay? So let's look at the next thing. Let's go try the next thing. Now, if you look at this next part right here, it says that dextrans is secreted, basically comes from sucrose, right? You see this right here? You see sucrose glucosal transferase? Even if you did not know what that enzyme does, you know one thing. The products of it are going to be glucose and fructose. Am I right? Everybody follow me? Good. Now watch this. Let's keep going. Now, amylase. Where do we find amylase? Okay. Karina says saliva. Nada says starch. Amira, saliva. Okay. So there are 2 places in the body where we find amylase. What are the 2 places? Good. In the mouth and in the pancreas. That is a test question. Believe it or not, they do ask that as a test question. So you can find you can find amylase in the mouth or the pancreas, right? Now listen to this. If you remember this, this will be all amylases. All of your amylases have a 1,4 linkage, okay? All of them have a 1,4 linkage, except gamma amylase, which has 2, has a 1,6 linkage and a 1,4. Now, I always like to say gamma, the G in gamma means greater. So since G means greater, that means it's going to have a greater amount of linkages, 1,6 and 1,4. So all amylases have a 1,4 linkage, but gamma amylase has 1,6 and 1,4. Does everybody follow me there? And if you get to the test, trust me, it'll make sense once you look at the question. If you see a question and they ask you about which type of linkage it is, it's going to make a lot of sense, okay? All right, everybody got that so far? Okay, yeah. So what I was saying was, you know how you have your different amylases? So you can have an amylase in the mouth, you can have an amylase in the pancreas, right? And amylase is basically how you begin to break down your starches into sugars. Well, all of your amylases, right? All of the amylases have a 1,4 linkage. Okay, you got that, Stan? You see that? So all of them have a 1,4. But the gamma amylase, the G in gamma, think of greater. Greater means more. So they will have a 1,6 linkage and a 1,4 linkage. They're going to have both of those linkages. So that's just how you remember that for the test, okay? All right. Now, let's get to some fun stuff. All right. Now, so basically, they have this thing. Yes, that's right, Amira. So they have this thing called glycogen. All right. Okay, Andy, what is the glycogen, Andy? What's glycogen? This is for Andy. Okay, I like that. This is a polysaccharide. That's true. Good. That's right, Stan. Right. So it's actually, right, it's the storage form of glucose, right? Good, Nada. That's right. So it's the storage form of glucose, and we store glucose in the liver. Okay? Now, that's important, right? Now, watch this. If you have, here's glucose, right? Here's a glucose, here's another glucose, here's another glucose, right? And so on, all the way down, right? Now, glucose, it could be like basically what we call linear, like you could connect each glucose in a linear fashion, or you can kind of connect these glucoses like in this branching fashion. Y'all see this? Everybody follow what I mean? So there are different ways you can connect the glucoses together and put them in the liver. Well, I always like to think of branches as having more branches. So since I have more branches, I think of 1 plus 6, which is equal to 7. Linear, to me, is less branches, so I think of 1,4. Now, let me explain that again. A 1,4 linkage lets me know that that glycogen is linear, okay? 1,6 linkage lets me know that it's branched, okay? That's what they like to ask on the exam. They may say, which one is branched, which one is linear? Think of more branches. So if you think of more branches, you say, oh, 1 plus 6 is 7. That's more branches than 5. You all follow me on that? Y'all got it? Okay, perfect. Okay, good. Now, watch this. So, Ruby, do you get that, Ruby? Does that make sense? Okay. All right. So let me just say this. Okay. So you know when we eat and we're digesting glucose, right? If we have too much, what our body will do is our body will say, hey, let's store some of that glucose to make, and we're going to make glycogen, right? We're going to store it. And in order to store that glucose as glycogen, we're going to need to connect those glucoses together. And what we do is we use linkages. Here are different linkages, right? And when we connect these things together, we can use either a 1,4 linkage between each one, or we can use a 1,6 linkage to connect the glucoses together. If it's a 1,6 linkage, we say that it's a branched linkage, like for glycogen. If it's 1,4, we say it's linear. Now, that glucose then will go, the glycogen will go to the liver, and it's going to stay there until we need it. Now, when we need that glycogen, we're going to have to break it down. Does that make sense to everybody? Because if we need the glucose, we need to break the glycogen down. Does that make sense? Everybody got that? Okay, now watch this. There are only 2 places in the body. Okay? 2 places in the body. This is deep. This is very deep. Yes, good way to connect it. Good. That's right. Good. Good, Karina. All right, so watch this. 2 places in the body. Very deep. The first place, in the blood. The second place, wow, that's deep, isn't it? Isn't that deep? That's a deep concept. In the blood or not in the blood. That's all we got. Now, you may say to yourself, that is too simple. Of course, I know that. But guess what? Believe it or not, when we get ready to talk about edema and other things like that, or filtration, you understanding this is going to save your life on the exam. Save your life. Because watch this. If, for instance, here's my bloodstream. You see the bloodstream right here? Okay? If in the bloodstream, these little blue boxes, these are proteins. Y'all see this? Here, see the proteins? Okay? If you have increased proteins, right, in the blood, what does that mean regarding, and out here is tissue, okay? Here's your tissue. If you have increased proteins in the blood, what does that mean about proteins in the tissue? Exactly, Amira. Good, Karina. That's right. Good. So that means then it's either in the blood or not in the blood. Now watch this. How does this make sense? Why am I using that? Because we just talked about glycogen, right? Did we just not talk about glycogen, right? And we said that glycogen is the storage form of glucose, right? Now watch this. If I increase glycogen, what happens to my blood glucose? Okay, Amir says it's lowered. Nada says decreased. Karina says increased. Come on, I want some more answers. I got Karina. Okay, Satara, decreased. Kayla, decreased. Stan, decreased. Andy, decreased. Prathima says increased. Pedro, decreased. Andrea, Procky, decreased. Andrea, increased. Interesting. All right, now watch this. Did you know if you increase the glycogen, then your blood glucose will go down? Yes, exactly, Stan. That's right. Because glycogen is a bunch of glucoses together, right? And if those glucoses are going to the liver is a tissue. Is that in the blood? Is liver in the blood? No, it's not. So that means you're increasing glucose in the liver, right? But it's decreasing the glucose in the blood. You remember I just told you, there are 2 places in the body, in the blood or not in the blood. Now do you see why I use that term, in the blood or not in the blood? Because that is going to mean so much. Even when we start talking about osteoporosis, right? Or parathyroid hormone, And we talk about calcium. Because if you increase calcium in the blood, what happens to your bones? Right. You decrease the calcium in the bones, and the bones become more brittle. Does that make sense to everybody? Yes. Okay. All right. So now let's keep going. Let's see if we make sure we understand this. So now, say for instance, we're increasing the glycogen, right? That makes sense, right? So we're storing the glycogen. So we're increasing glycogen, which you said that if we increase glycogen, that means that we're decreasing blood glucose, right? But if we decrease blood glucose, we might need some blood glucose, right? So we need some. So in order to get the blood glucose, what do we need to do to the glycogen? What do we need to do? Break it down. Good, Andy. Perfect. Exactly. So that means that we need to break these bonds between the glycogen, right? Well, not glycolysis, Prathima. Glycolysis is breaking down the glucose. This is breaking down glycogen. So we actually call this glycogenolysis, not glycolysis, but it's called glycogenolysis. Does that make sense, Prathima? You got it? Okay, perfect. Now, what if we could not break down, or what if something was wrong with the enzyme that breaks the glycogen down? What would happen? Right, but what would happen though? Like, give me what do you think I would expect to see? Glycogen is the storage form of glucose, right? But if we did not have the enzymes that could break good, Andy, that's right. Andy is right on it. You're going to increase the amount of glycogen. Does that make sense? Because if you can't break the glycogen down, then you're going to increase the amount of glycogen. Now, what is going to happen to the liver as a result of that? That's right, Amira. Hypoglycemia, hepatomegaly. Good, Celine. That's exactly right. So Celine said it. Hepatomegaly. Oh. So that means that all of your glycogen, watch this, glycogen storage diseases. Every glycogen storage disease you have is because you cannot break, or you're missing an enzyme that can break down glycogen. Does everybody follow me? Everybody understand that? So that means then every single glycogen storage disease, one of the symptoms, right, one of the signs is hepatomegaly and hypoglycemia. That makes sense. Everybody with me? Okay, everybody got that? Well, you may not believe me, right? I don't think y'all believe me yet. You don't believe me, so I got to prove it, right? That's okay. I don't mind proving it. Let's take a look at this. So I came up with this mnemonic, right? Called Very Hot Camp. You ever heard of this? Anybody heard of this mnemonic? Very Hot Camp. Okay? Now let's take a look at it. Let me see if there we go. So as soon as I get here. Okay, here's the V. Here's my H. And all of the camp. Okay, everybody see that? So each one of those, and I said, well, very hot camp, glycogen storage. So as soon as you think of glycogen storage, I want you to think of glycogen as the storage form of glucose, your sugar. Why do you store it? Because you may need energy later. Why do you need energy later? If you are at a very hot camp. I know it's corny, probably don't make a lot of sense, but at least you remember it, right? Okay. All right. So that's the way you remember the mnemonic. Very hot camp. Now watch this. The V is for von Gerkes. That's the name of the V, the von Gerkes. Look here. Von Gerkes has the letter G in it at the end, von Gerke. That G, I always like to think of glucose. So now I know that von Gerkes, the problem is a problem with glucose 6-phosphatase. So on a multiple choice test, and I see Gerkes, all I'm looking for is something with glucose. Everybody follow me? And I keep moving. Okay, now watch this. Now, the H in hot is for HER's disease, H-E-R. When I think of HER, H-E-R, the problem is a phosphorylase. Okay, the problem is a phosphorylase. I'll tell you that in just a second. Follow me here. Now, the next thing is called A, B, C, D. Everybody knows their ABCs, right? A, B, C, D. Y'all see A, B, C, D? Anderson is a problem with the branching enzyme. Corey is a problem with the debranching enzyme. Ah, do y'all see that? So A, B, C, D. Everybody understand that? Everybody get it? Tell me yes or no. Okay, Kayla says no. Okay, problem. Good, perfect. I like when you say no, because that helps you do it. Watch this. So, you remember when we said that every glycogen storage disease is due to an enzyme deficiency, right? So watch this. The Anderson glycogen storage disease, this one right here, Anderson, the problem with Anderson is that they have a problem with what we call the glycogen branching enzyme. That's the enzyme. That's the name of it. It's called glycogen branching enzyme. The problem with Corey disease, it's a glycogen storage disease, but Corey's is due to the glycogen debranching enzyme. You follow me so far? You with me? Okay. So, the mnemonic, the way we remember that, is A, B, C, D. Anderson, the problem is branching. Corey, the problem is the debranching enzyme. Does that make sense now? Everybody understand that now? Okay, Kayla says yes. Okay, good. Prathima, good. Okay, Ruby, you got it, Ruby? Karina, yes. Celine, yes. Ruby, no. Okay, Ruby, do you have a microphone? You have a microphone, Ruby? Okay, go ahead and turn your microphone on, because sometimes it's easier when I can ask you, and then I can see exactly what you're missing. Just turn it on real quick.
It's green. So Dr. Corey disease is a
And it should turn green at the top. Okay, I can hear you. Can you hear me? Okay, so tell me which one you're having problems with. Hello? Can you hear me? Okay, so I'll just go through and I'll just say this again. So the mnemonic, so Corey's disease, the problem is with debranching enzyme. That's the enzyme deficiency, okay? The problem with Anderson is the branching enzyme deficiency. Those are the deficiencies that cause these diseases, okay? All right. Can you hear me, Ruby? All right. All right. So let's look at the next one. The next one is called McCardell's. This is probably the easiest one because McCardell starts with the letter M, right? M. So guess what? The problem with McCardell's is a problem with muscle phosphorylase. When you say branching, you mean the link. Exactly, Jessica. That's right. When we say branching, we mean the linkage, how they're linking. Very good. Do we need to know the characteristics of the disease? No. That's a good question. The answer is no, Stan. The answer, what they would ask you if they ask you anything is they're going to ask you about basically the enzyme deficiency. They're not the characteristics. The only one that they really would ask about characteristics for is McCardell's. And the only reason why is McCardell's will give you like proteins in your urine. So with McCardell's, you'll get this myoglobinuria, right? So you'll get like proteins and things in the urine. That's the only difference, okay? But all of them will give you hepatomegaly. Now, here's what I would tell you to do. The easiest ones you can remember. The other ones you get by process of elimination. So if I asked you all, what are the easiest glycogen storage diseases you can remember and their enzymes, which ones would you tell me are the easiest for you to remember? Which ones would you all say? Okay. Andy says VGD, Von Gerke's, the ABCD. Gotcha. Corey's, the branching. Okay, gotcha. Okay, perfect. Exactly. Right. So, okay. So basically the easiest ones that most people can see is McCardell's is easy, Anderson, Corey, Von Gerke, right? So that means if you knew 4, right, out of the 6, could you eliminate the other 2 in an answer choice? If you saw it in an answer choice. Does that make sense to everybody? Yes. Okay. Now, that brings me to a very good point. The way you do well on this exam, the way you pass the NBDE, and trust me, I've been doing this since 2009 with over 500 foreign trained dentists who've already taken the class and U.S. trained dentists who've taken this class. The same process applies. It's not about if you know all the right answers. It is your ability to eliminate wrong answers. Does everybody follow me? So you don't have to learn everything. You just need to know what you know well. Okay? And I'm going to teach you how to do that throughout this course. Okay? All right. So is everybody good with this? Everybody good? Sounds nice? All right, let's keep moving. Now watch this. This next one is inulin, and I'm going to put this over on the whiteboard. How many of you have heard of inulin before? This is a favorite on the test. Inulin. They like this one, right? All right. What is inulin? What is inulin? Good. Karina says it measures GFR. What else is inulin? Good, Andy. That's right. Andy is all, that's right. It's a polymer of fructose. No doubt about it, right? It's definitely a polymer of fructose. And we use it to measure GFR. Good, Stan. Now, watch this right here. I'm going to put up a formula. And I want you to tell me what this formula means. All right, let's see here. Let's see. Let's do. Oh, you're jumping ahead, Karina. I haven't even got to that yet. Urine flow times urine concentration all over plasma flow, right? Plasma concentration. Now, as soon as I put this formula up here, and I put, I'm going to put a variable as a B, and put a B right here. A B can mean anything, right? What is this the formula for? Can anybody tell me what this formula is for? I got you all. No. No, it's not. Not GFR. I know what you were thinking. And I told you B equals any substance. Any substance. So B means any substance. So what is this formula for? Anybody know this? Oh, go ahead, Sakshi. Look at Sakshi. Good job, Sakshi. That's right. It's the formula for clearance. Exactly. Perfect. Exactly. Okay, everybody see that? Now, what she said, though, was when Sakshi said, okay, that's the formula for clearance, right? That formula really does look like the formula for GFR, doesn't it? Except all we do is replace inulin, right? The urine flow of inulin times the urine concentration of inulin over the plasma, right, concentration of inulin. So now, just by changing inulin and using inulin, that's what it is. Oh, okay. Stan is asking, okay, what is clearance? Okay. So Stan, you remember I told you, Stan, what are the two places in your body? What are my two places, Stan? Good. In the blood. That's one place. Or outside the blood. Okay, gotcha. Clearance, Stan, is when you urinate. If you get rid of something, if something leaves the body, you're clearing it from the body, right? So as you clear it from the body, that means that it's less of it there. So look at this, Stan. If I increase the plasma concentration of morphine, let's use morphine, right? If I increase the plasma concentration of morphine, and as a matter of fact, I just taught this tonight to our NBDE students. We were doing pharmacology tonight. If I increase the plasma concentration of morphine, what happens, Stan, to the clearance of morphine?